Hi there, this is going to be one of two videos, maybe even three, of just giving you some examples of proving or verifying a trig identity. I'm going to pick one out of the textbook here so that you can check it with the work in the book, and you can double check the answer in the process. So this first one is on page 530 in your textbook. It's example number 3. And it says cosine of theta times secant theta minus cosine of theta is equal to sine squared theta. So we'll show you how this works. The first thing I'm going to do, it's always a good rule of thumb to put everything in the equation in terms of sine and cosine. So we have all sine and cosine except for this one term right there, secant theta. So what I'm going to do is replace that with 1 over cosine, because secant is equal to 1 over cosine. And that's the only change I'm going to make right now. So I'm just taking this one step at a time. I have cosine theta times the quantity 1 over cosine minus cosine, and that again equals sine squared. So that's the only change I made. Now, just trying out the distributive property here, take a look at this. If I just multiply cosine times 1 over cosine, what does that equal? It equals 1. And cosine times cosine, of course, equals cosine squared. So I'm just using the distributive property here, and that changes the left side of my equation to be 1 minus cosine squared theta equals sine squared theta. And I'm almost done at this point, because one of my basic trigonometric identities, the very first fundamental Pythagorean identity, is that sine squared plus cosine squared equals 1. So I'm just going to add cosine squared to both sides here of this equation, and I have 1 equals sine squared plus cosine squared. And I'm done. That is all proven. We could say QED. Just kind of a fancy way of saying we're done.